Hello students, let's start with geometry now. So this is the additional section of geometry that I've added recently, and here we are going to discuss many different properties of geometry. Now, geometry, we all know it's already a huge topic. It has many properties and many concepts involved in it. Somewhere it's not possible to cover everything, but considering different aptitude tests like MBA Entrance exams or your BBA Entrance exam or Law Entrance exams or even your placement aptitude test, there are certain important and frequent kind of properties which we see in different questions. So yes, my focus will be on that only. So to start with, let's discuss the properties that we have in angles and lines. So to introduce, this is a simple definition of angle. Nobody is going to ask you the definition in aptitude test, but what is an angle? It is formed by two rays originating from the same point. So you can call this as your angle. Let's come to the next slide. Now, let's understand different kinds of angles now. I hope you all can recall what is acute angle. You all learned it in school. What is acute angle? Acute angle looks something like this. And if I have to define it, acute angle is something which is less than 90 degrees. So any angle which is less than 90 degrees will be called as an acute angle, right? Let's see the next one. Right angle. I hope you all know what is right angle. Right angle looks like this, and it is denoted by this kind of a symbol in angle, or you can clearly see a square or a straight line at B. So that is the denotion of right angle. And right angle simply means it's 90 degrees, right? So angle which is 90 degrees will be called as right angle. Next, let's say obtuse angle. What is obtuse angle? You can clearly see it in the diagram. It looks something like this. And if we have to define it technically, theoretically, obtuse angle is something which is more than 90 degrees. Now we all know the angle which is more than 90 degrees obtuse angle, but to be precise, more than 90 but less than 180 degrees, right? So that will be called as obtuse angle. Let's see some more type of angles in the upcoming slides. Straight angle. Now what is straight angle? Straight angle is nothing but straight line. So if you have a straight line like this, or angle ABC will be called as straight angle, and ABC is having a measurement of 180 degrees, right? This is your straight angle. Let's see the next. Reflex angle. What is reflex angle? So I believe some of you might be knowing the term, but in case if you're coming across this term of reflex angle for the very first time, please make a note of it along with the diagram. So you can clearly see this angle and you will say this is an acute angle. Yes, this is an acute angle if you do the measurement of the inner part of this angle. But if you do the measurement of outer portion of this angle, this outer portion measurement is called as reflex angle. Is this clear to you? So if I have to define it, what is reflex angle? Reflex angle is something which is always more than 180 degrees and up to 360 degrees, right? Because entire 360 is nothing but the measurement of the circle. So reflex angle is more than 180 and less than 360. And the next angle is this complete angle. What is complete angle? So it's a complete circle actually. So the complete measurement of this circle or this angle will be 360 degrees. So angle B will be called as complete angle, and this is 360 degrees. But many times I have seen that people might have forgotten the term reflex angle. So that was something new or something which you might have forgotten. Let's come to the next slide. Next, supplementary angles. Now we are discussing different kinds of combination of angles. So what are supplementary angles? So if one of my angle is angle ABC, which is 75 degrees, and my other angle is, let's say, 105 degrees, angle PQR. So if you add the total, if you add the measurement of these two angles, so these two angles measurement or total measurement is 180, right? 75 plus 105, that is 180 degrees. So if the measurement of any two angles, the total measurement of any two angles, or if you can have three angles as well, if that is 180 degrees, then that is called as supplementary angle. So for the time being, this is a pair of supplementary angles. Next, angle in linear pair. So in case of angle in linear pair, this is angle AOB, which is 60 degrees, and the linear pair will be like this, an angle AOC, that is 120 degrees. And in this case also, whatever we learned just now in the previous slide, I'll repeat it. If you add the measurement of these two angles, it's 120 plus 60, that is 180 degrees. So as the total measurement is 180 degrees, the pair angle AOB and angle AOC, this is a linear pair, and I can also call it as a supplementary pair of angles. Is this clear to you? We can get supplementary angles in different ways also. We'll see that in upcoming diagrams or wherever we come across such thing in any question. So we already discussed this. Let's see complementary angle. So the way we have a term supplementary angle, we have one more term called as complementary angle. And I believe some of you must be knowing this. In case if you have forgotten this, what is complementary angle? Let's discuss that. So if I have an angle ABC which is 32 degrees, and if I have one more angle which is PQR which is 58 degrees, and if you add these measurements, that is going to be a total of 90 degrees. So when the total measurement of any two angles, if that is 90 degrees, then it is called as a complementary pair of angles. If it is 180, we call it supplementary. If it is 90, we call it as complementary angles. I'll give one more typical example that you will see in different questions as well. If this is a triangle, if this is a right angle triangle, this is right angle triangle XYZ, we all know this is already 90 degree. So angle X and angle Z, if you add them, angle X and angle Z, if you add them, that is going to be 90 degree as well, because the total measurement of all the angles in any triangle is 180 degrees, right? We know that. So in that case, as this is already 90, so the measurement of the remaining two angles here, if you add them, that total has to be 90 degrees. So though we don't know the individual measurement, but we know that the total has to be 90 degrees. So that is also called as a complementary pair of angles. Are the properties clear to you? We'll discuss certain things again with some actual questions and with some upcoming slides. Let's move on to the next one then. Next, let's have parallel lines and transversal. So how it looks like, you can clearly see. Let's have a diagram first. These are two parallel lines, and when we have a common line which intersects both the parallel line, that is called as transversal. Let's discuss corresponding angles first. So what are the different angles you can see? So we can name all the angles which are available in this diagram. You can see A, B, C, D, W, X, Y, Z. These are 8 different angles, and out of which let's understand which are called as corresponding angles. So angle A and W, can you see that on the left hand side? So they are called as corresponding angles. Angle B and X, they can also be called as corresponding angles. So with this we are done with two pairs of corresponding angles. In the same way, there are two more pairs possible. Can you find out them? The next two pairs are C and Y. This is one more pair. This is a third pair of corresponding angles. So many times people see the corresponding angles on the upper side. So which were A and W and B and X. People don't see it immediately, the angles which are available on the lower side of the line. So C and Y, they are corresponding angles as well. And the same way, D and Z will also be called as corresponding angles. And in this particular diagram where we have parallel lines and a transversal, so if the lines are parallel, so whatever the corresponding angles that we have got, or whatever the pairs we have written till now, all those pairs are equal, or in the other term it is called as congruent. So corresponding angles will be congruent. So individually A and W, they are congruent, that's one pair, and in the same way B and X, that's a different pair, but they are also congruent. So B and X are congruent, or they are equal. I hope this is clear to everyone. So this is corresponding angles. We're done with it. Let's see the other kind of angles in the same diagram. So the next kind of angle that we have, that is called as alternate angles. What are alternate angles? In the same diagram, these are all the different angles we have, and let's understand alternate angles now. Now C and X, they are called as alternate angles. Now wherever this Z is getting formed, so I'm just writing on the other side, right hand side, So wherever this Z is getting formed and the two lines need to be parallel. That's important. That's the important condition. So these are called as alternate angles. Next pair of alternate angles is this, D and W. So this is another kind of a Z. You can say a mirror image of Z. Though it doesn't look like Z exactly, but yes, you can call it as Z for the time being. So wherever these Zs are getting formed, the angles are nothing but alternate angles. And in this particular diagram where we have two parallel lines and a transversal, the alternate angles are always equal or they are congruent. So angle C and X, they are congruent, or angle D and W, they are also congruent. Let's come to the next diagram and the next kind of angles. What are interior angles? Interior angles in the same diagram, these are all the angles we have, and C and W, they are called as interior angles. So in short, the angles on the inner side of the parallel lines, they are called as interior angle. So C and W, that's one pair of interior angle. And in the same way, can you spot the second pair? D and X, that is also one more pair of the interior angle on the inner side. So after this, let's understand the property for interior angle in this particular diagram. So interior angles will be supplementary. Now what I mean by that, the measurement of angle C and measurement of angle W, that has to be 180 degrees, and in the same way angle D plus angle X, if you add the measurement, that has to be 180 degrees in this particular diagram where these two lines are parallel. So interior angles are supplementary. And let's see the next kind of angle then. Vertically opposite angle. Now this is very simple actually, and let's see the properties. So we can spot many different vertically opposite angles here. So A and D are opposite angles, C and B are opposite angles, and these are two more opposite angles. Now, irrespective of parallel lines or in any random diagram, vertically opposite angles are always congruent or always equal. So even if I just draw two lines like this, so vertically opposite angles, these are two vertically opposite angles which will always be equal, and these are two more vertical opposite angles which will always be equal. So with this, we have discussed some of the different important properties of parallel lines and transversal, and also of different angles. We'll try to utilize them in upcoming questions. So the next video will be for the questions, and we'll have a small kind of revision of whatever we have learnt in this video.